right, listen up. A person standing on a roof of a building throws a ball directly upward. The ball misses the rooftop on its way down and eventually strikes the ground. The function, which is up there at the top, I have f of t, they have s of t. Let me change that really quick. Make it consistent with the book. Well, this was actually being consistent with physics, the s, but yeah, it is annoying. Okay, s of t equals negative 16t squared plus 64t plus 80. Real quick for a visual. Now we'll put that in there. Let me show you what that looks like before you get worried about copying it down. Negative 16t squared. Ladies and gentlemen, your full attention, please. Brandon.
What?
I'm not feeling very patient right now. Thank you.
Okay.
Okay, so, whoops, I put in t.
Does that mean feeling very impatient?
That would be a good guess.
Oh yeah, that's why I get A's.
Okay. Now, here's what the parabola looks like if you want the visual, and I apologize that I can't shift the scale on both, so that we wind up with a, okay, when this thing starts, we're pretty close to it, this thing starts at 80, that's its y-intercept, okay? And then from there it goes up to 144, I checked, back down to 0. That's why this parabola, from 0 to whatever that number is a good description of a ball that was thrown off the roof and does not land back on the same roof. Okay? Now, the first question that they give about this parabola, find the ball's average velocity between the time it was thrown and 2 seconds later. Find the ball's average velocity between the time it was thrown and 2 seconds later. I wish I could widen this parabola out a bit, but what we're looking for then, average velocity, what should that make you think of?
Oh!
dq is one thing, but more simply, back to algebra 1.
Slope.
Slope, yes. This should be slope. So if that's, okay, that's about 5, that's about 2. It's really the slope between those 2 points. And that'll represent the average velocity of the ball between the first couple seconds. What would you expect that slope to be, positive or negative?
Positive.
Shallow or steep?
Steep.
Steep. I'm not going skiing with you if you think that's shallow.
Well.
After that, it says, that's part A, just so you know what we're looking for.
I just like to roll down the hill.
That's right.
Falling down the hill.
Well, that's really fun, except the falling part. The rolling part can be
The
fun.
rolling part can be. Okay,
It goes both ways.
B, find the ball's average velocity between 2 and 4 seconds after it was thrown. So here's the point at 2 seconds, and then at 4 seconds, it's going to be somewhere down here. What would you expect that slope to be, positive or negative?
Negative.
Very negative. Steep or shallow?
Steep.
Okay, so do you guys have a visual of what's going on here? We've got our parabola, hits the ground around here. We're looking for this slope, and that's the definition mathematically of average rate of change. It's the slope of this secant line. Secant is Latin for sever, to cut. It cuts across. It's like a shortcut. Pardon?
Nothing.
Okay. I like the force motion
Oh,
there.
me, it was the canter, because, you know, can't.
Secant, canter. They may have the same Latin root, but I don't know where that one comes from. Okay, I'm going to erase these lines. Now, I added something to the directions on Friday. I said you must use
The GQ.
the DQ. So let me quickly go through finding the DQ, as I'm sure you all did successfully on the homework, so I don't need to go through every single step. The function is s of t equals negative 16 squared plus 64t plus 80. The difference quotient is f of t plus h, stay with me, which means I put t plus h in for every t, minus s of t. Okay, so I have to put t plus h in for that t and square it. I have to put t plus h in for that t and distribute the 64. The plus 80 just comes along for the ride. I FOIL t plus h squared, t squared plus 2ht plus h squared. I distribute the 64 to the t and the h. I distribute the negative sign to the 16t squared, the 64t, and the 80. Then I distribute the 16, and after that I've got a minus 16t squared and a plus t squared. minus 32ht gets to live, minus 16h squared gets to live, minus 64t and minus 64t kill
They
each
get to
other
die.
in a mutual suicide pact.
So it's like Mufasa versus Mufasa.
Yes. Plus 80 and minus 80.
I mean, Scar versus Scar.
Well and strangely
Never mind.
said, Lauren. Okay. When I'm done, if you do the difference quotient correctly, every term in your numerator has an h in it. And there's an h in the denominator. Cancel them out. This is my difference quotient. Pardon? T is fine. Oh, wait. This is a mistake right here.
Oh.
That should be a...
T and
Excellent. That should be a T in those two. Excellent.
I caught that.
Wait, where did you get that?
Oh, yeah.
This should be minus 32T, and this should be minus 32T.
Where did you get the T on the outside, or the H on the outside?
Okay, where did I get the H on the outside here?
You took the H out of it.
Took the H out. I like to think is reversing the distributive property. I had an H squared, and an H, which meant I could factor an H out of each of these three terms. And the way I think of that is you're always allowed to reverse the distributive property if redistributing it would get you back to the step
You
before.
always have to do that?
In this particular process, yes. You've always got to factor it out in order to get rid of the denominator. Okay? So this is my final difference quotient, and I left out the equal sign, which is bad math grammar.
That's F. It's an F, Mr. Bellabell.
That is an F. What would Mr. Booth do if I left out a verb?
He would smite you.
He would smite me, and I would deserve to be smit. Finn? That sounds wrong.
Smitten.
Smited?
Smited?
Yeah. Okay, now, there's how I found the, any questions on how I found the different quotient, given that you'll be finding one of these tomorrow? And I'll give you something parabolic, I'll tell you that much. Okay, so it won't be, I won't suddenly say, here's a sine wave, find the difference quotient. Okay, it'll be a parabola. So you won't have to do more than FOIL this. I mean, think about it. If that were to the fifth power, you'd have to do t plus h to the fifth. That would be terrible. Okay. Now, here's the advantage to using the difference quotient. Okay? Remember when you use the difference quotient, the biggest thing, h is the distance between the x values. If you forget that, you will use this incorrectly. So for part A, on this question, it says, it says, find the ball's average velocity between the time it was thrown and 2 seconds later. Okay, what's the time it was thrown? T, yep,
What number are we on?
61, part A.
What'd you say?
T equals 0. Brandon asked which number we were doing. Number 61. Okay.
61 part E.
No. Now, what does h equal? 2. H is the distance. Okay. They asked about what the average velocity was between t equals 0 and t equals 2. But this h is 2 because that's the distance between them. Okay? So let me write this in a way that might be clearer from...
What is the 2?
that's what I'm trying to explain here. From t equals 2...
I have a question.
Hang on. 2, t equals 2. Okay? In this difference quotient, this t is the starting time value, this h is the distance to the next time value. So that's why h is 2 here, because it's the distance from 0 to 2. Yes, Brandon?
Last year we did some, like, okay, can you take 8 out of the top?
I could take 8 out of the negative 32, the minus 16, and the 64, but it wouldn't help. It wouldn't simplify it at all. Okay? But yeah, it could. That's good to notice the common factors. Okay, so A says find the average rate of change. Well, that's what the difference quotient tells us. So in that case, this is going to be negative 32 times 0 minus 16 times 2. I'm just plugging in the t and the h. Plus 64. What does that get us?
32.
Yep. Yep, that gets me positive 32. Now this is a rate of change. We were talking about feet, and we were talking about seconds. That's 30. You got to put your unit.